So here's a really quick tutorial that I'm going to show, and what I'm going to explain about is basically these four examples that we have here. We have this example which has UV mapping. We have this example which uses some DATs to manipulate geometry. This example uses chops to manipulate geometry. And finally, this example uses the primitive SOP to do some expressions. So just going to quickly go through all of those. This is quite a fast tutorial. It's just me kind of flying through a few examples to help people out. But yeah, that's cool. If you have any questions, then yeah, throw it in comments below and I can help out. And yeah, hope you enjoy. So this is going to be a SOPs tutorial. And in the first video here, in the first example, what I'm going to just show is how to manipulate a UV map. So let's say we have a box here, and the texture coordinates of this box are set to box inside. And if you go into your samples folder, you can find the box map, and that is actually the default box which will come in, and it will texture perfectly onto a box which has its texture coordinates set to this. So if I apply material of a constant and I start to drag my mouse around, we can see that all of this box map is mapping perfectly. So the question is, how do we show a UV map? How can we see what the UV map is? And the easiest way to do this is if I middle click to branch, and I'm going to go into a point SOP, and I'm going to use the point SOP to convert our UV map to be our point positions. So if I go in, I can say add texture. I'm just going to use the add texture to take this expression. I'm just going to copy that and then go back to keep texture. And then I'm just going to go in and say input texture 0, 1 would be Y, then 2 would be Z. And then when I go into this, then I can see that when I just move my dog, I can see that we have a texture map here, a UV map, which matches this map here if this map was square. So if I just set this to fill, 1000 by 1000, we can see that it looks pretty much the same as this image here. So that's quite useful in that we can take this UV map, and if we want to, we can actually start editing that UV map as well. So what I could do is I can go in and I can say, let's group the points on the right hand side. So I'm just going to say group points. I'm going to make it a wireframe. I'm going to display my points so I can see what's going on. And I'm going to say, let's choose the bounds. Let's just move the center point over, oh my god, without going everywhere, and up, and just scale it down a bit. So there we have, I've just got these points here are yellowed, so they're the selected points. They're going to go into a group name called group 1. And then what I can do is I can say transform that by using a transform, selecting group, and then I can move just those points. So now just moving those points, we have here sort of weird UV map. And now what we can do is we can say, we can take this UV map and we can say, let's take the points from this model, and let's this 3D object, and let's apply the UV map to the 3D object. So what we can do is use a another point SOP to take texture, and the texture is going to be the point position of the second input, which is our UV map. So we're going to say input point X, Y and Z, and that's not input point X, Y and Z, it's input point 2, because this is the second input. And what we'll find here is that now, if we look at this box, our whole map has been warped, and if I start to move these points around, we can see that now we're actually editing this UV map on a 3D object in real time, and we can start sort of messing around with it. So there are a few other tricks that we can use with SOPs. So that was the first example of a UV map. What we could also do is another way of modifying the SOP is, rather than doing it in the SOP itself, we could actually do it in a DAT. So if I go in and create a new, I'm just going to create a rectangle, or maybe a grid. I'm going to create a grid. I'm going to make it a polygon grid. and I'm just going to hit W so we can see exactly what's happening here. And I'm going to give it maybe 5 rows and 5 columns just so we can kind of see what's going on. And then what I'm going to do is right click on my SOP output and choose a SOP to DAT. Now what a SOP to DAT allows us to do is get all of the point positions from this SOP. So I now have everything here that is in my grid. I have these are the point positions, these are my normals, the weight of the point, and the index of the point. So what we can do is use a DAT to SOP and then merge whatever we have here back into our geometry. So if I just lay down a null and then I just drag this onto the points DAT, then we suddenly have, you know, exactly the same geometry here. Nothing has changed at all because we haven't done anything in here. And in order to do something in here, we need to kind of create some kind of, we could replace these values completely just by using a table. I'm just going to use a table, and I'm going to set its exact dimensions. So that its row number is going to be op sop21 dot num rows, and its columns will just be 2. And this is going to be, you can see that we have 0 to 25, and here we have 0 to 25, and this is actually just going to be the x and y of this table here. In fact, actually what we might do is say minus, let's not even have that, let's just get rid of -1 on here, and get rid of x and y, because otherwise it's going to make life a little bit easier. And then what we can do is use an evaluate dat with a little expression written in here, and the expression is basically going to be I'm just going to say me.input cell for, I think it needs to have 7 columns. Yep, so I'm just going to give it 7 for now. This is a really rough example. You can make this a lot neater. 6, 7. Just going to say me input cell, me input cell, me input cell. We'll just do that. Why not? In fact, actually, we don't even need that. I think we only need up to 4. So I might just delete out everything here. And then I'm going to add a row below. So if I put 0 in here, for example, you can see that now all the indexes are 0. So 0, this should actually just be me.input cell, which is fine. And then what we're going to do is the second one is our x coordinate, and we're going to put like an offset in here. So we could just say me.input cell plus the op table 1. I'm just going to type it in here without table 1. And it's going to be me.input row, which is 1, so 1 will be 1. Me.input row and column will be 0. So that gives us this -0.5, and if I put a value of 1 in here, then that means that the value should change. It hasn't because I've done something wrong. Input row 1, column 0. Input row 1, column 0. Let's just put 10 in there. No? Oh yeah, it is changing. It's just I'm being an idiot. I haven't seen it. It's changing that first one. This one here. I just think that, so this is, I'll just put x and y back in here. X and y. Yeah, cool. And then I just need to add that back in. There we go. So what we have now is we can say input 0, we can say input 1, and then after that everything will be me.input cell. And now what we have here is a one of our points is now offset by quite a large amount. If I set it to say 0, then you can see there's nothing happening there. 0.1 will move my point a little bit. If I go like -0.5, then our point's going to be offset by that amount. So we can actually drive this this expression using this. We could even use a chop. So if I made a like a wave chop maybe, and then I could use the index of the chop samples, but I'll just convert it for now for simplicity. So I'm just going to convert this chop to a big long table, And this is called chop to 1. I'm just going to say chop to 1. And then we should get something along the lines of this, because our wave is now affecting our geometry. We can change things like the period, and we can start phasing it, so we can kind of start making geometry move. We can offset, we can use the amplitude to kind of make it warp. So we can kind of do all these little bits and bobs, you know, to make this work. So that's how you do basic DAT offsets with SOPs. So what I just showed there was one way to basically use a chop through a DAT to control this geometry. You can actually use chops directly as well. So what I could do is I can say, let's create a line, and lines actually can go into a chop too. I'm using, this is the old way of working. Actually, you can now just delete this line and generate geometry straight through the chop 2, so forgive me for doing that. I can say, let's bring in a, maybe not audio, maybe I'll use a wave again. And we're going to use this wave to drive this chop. And the wave comes in and it says here that TX, TY and TZ were not found. So what I can do is I can say, okay, so I've got channel scope, I'm just going to say chan 1. And I'm just going to set this to the point's position in Y. And then suddenly we'll see, when I do it, that right now the mapping is set to 1 sample to each point. And if I go right click home all, then we can see that we have our waveform in a SOP format, and we can move it around, we can change the period to something ridiculous, and we can also, if we want, rather than change the point, we can change something like the normal as well. And what's cool about changing the normals is that we can use the normals. This is a trick that Marcus showed me quite a long time ago. What we can do is use the normals to drive particles. So we can see here our sine waves kind of flying up as a particle system. In fact, we can see it better if I apply a wireframe. So here we go. So this is kind of our sine wave moving along as a particle system. But what's really cool is if we say, let's create, let's not have our particles last very long, and let's birth quite a lot of them. So let's birth a whole load of them. And now we're getting this kind of particle system made out of a chop. So as I start moving this wave around over here, I can say, okay, so that's a sine wave, I can say a Gaussian wave, I can say let's put it into a square, or I can move the bias, so I can kind of change that around so we get this kind of choppy effect, change the amplitude, and then push the amplitude back up so you get these bursts. And this is kind of really cool with audio devices in, so if I actually just use my my microphone, which is here, and just chuck that into the chop 2, then you can see that as I talk, the particles are starting to expand. And if I put a math on that, range it up a bit, maybe to 10, and then drag that into the chop 2, then suddenly we have like our particle system moving to our current sampled audio. So that's our 735 samples coming in and firing out as particles, and the higher the volume, the further the particles will fire. So the last thing I'm going to show in this tutorial will be, I'm just going to take a grid, and what I'm going to do is, in fact, actually before I show that, I'll just quickly show a sphere. This is the classic thing that everyone keeps going for. You create a polygon, you then use a facet SOP, and you can actually compute the normals, turn on unique points, and that gives you that low poly look, which you probably have seen so many times in VJ sets or in Cinema 4D or other things. In fact, if I do the noise before it rather than after it, then you can see here that you have a kind of effect. So that's quite cool. That's one thing just quickly to show, but that's not truly what I was wanting to show. I was wanting to show taking a grid such as this one and using the primitive SOP to drive that. So what we can do is first of all facet it. Faceting being useful because we turn unique points on, we compute our normals, and now what we can do is, if I use the transform SOP now, you'll see that when I scale, it scales the entire thing up and down. Now, what the primitive SOP allows us to do is to manipulate just one primitive, and that would be one of these faces. So we can do that by turning do transformation on, and actually I'm just going to turn my wireframe back off. And if I start scaling, we can see here that now I can suddenly scale everything in the grid. So that's quite handy. But what I can also do is I can start to use things like this input prim. So what I can do is use this input prim, which is already set in the pivot, and I can use it, for example, to rotate. So if I use me.inputPrim .index, then you can see that actually now what I can do is I can rotate my entire grid depending upon the index of my primitive. And what's really cool about this is that what I can also do is use the sort SOP to choose primitives and sort them by X, by Y, so I can change how this looks. I can make it random, so we get random sort of rotation here. I could say distance, or my favorite proximity to point, which will give us this circle. And then what we can do is maybe we have this input primitive type index, and we could say maybe it's going to be plus me dot abs frame, or time dot abs time dot, I can't even remember how you do this again. There we go, time dot abs frame. And you can see now that we have this cool kind of circular sort of primitive effect. It gets almost MoGraph like if you start using it. It's quite heavy, as you can see. I'm running at 25 on this laptop here, so it can get quite heavy, which is where you start using instancing. But it's quite handy for some of the smaller effects if you want to kind of, I could kind of multiply that by like 40 or something. It's going to make it faster. I can have it as 10. And we can put any expression in there, to be honest, so that's kind of cool. We can say if it's greater than this, don't do this, otherwise do this. So we could say do this if me.input prim .index is greater than 10, else just don't do anything. And you can see that it's actually not now moving those central ones. I could say else maybe we just want to set it to 45. Maybe we want to, we can just change that around depending on the rotation. That can also be scaled, and we can do that with any of these parameters. We can scale as well. We can change the attributes, but so we can change the color by adding. We could add the color. Could be me.input prim divided by .index divided by the number of input prims, which I think is me.numprims, maybe. Nope. That is not it. Oh, I have to choose the input because it won't let me do it on this. So I could say, like, I don't know, ops sort 1 .numprims. There we go. That's better. And now we get this kind of blue happening all the way to the center. If I do that on all of them, then we're just going to get this kind of this gradient fall off from black and white. So it's quite useful for things like that as well. And you can see, again, this is super heavy to do. If it was slightly less heavy, so if it was 5x5, for example, then life becomes a lot easier, everything kind of runs. But yeah, this is just to show what the primitive SOP can and can't do.